Okay, welcome, ladies and gentlemen. This is an addendum to 6.1. I found out that I omitted a couple things that needed to be on there that I just kind of blanked my mind. The first thing's the big one, the DMS. And let's just go ahead and get right into this. We're going to do two different things. We're going to go from DMS to decimals, and then also from decimals to DMS. I'm going to explain a little bit what that means. All right, so DMS is just an abbreviation for degrees, minutes, and seconds. And what it is just a way to represent decimal parts of a degree into smaller parts called minutes and seconds. So we can take an entire circle and break that up into 360 degrees. So we know that already. We knew that already, breaking up a circle into 360 degrees. But then what if I just had 1 degree? We need some other way to read like the measures in between. If this was just 1 degree, what would be a measure inside of this? And this is where we break it up into minutes and seconds. Just like we break up an inch into eighths and sixteenths, or feet into inches, yards into feet, that sort of stuff. Breaking something into smaller parts. All right, so what this is going to look like is this. This would be a DMS measurement here. So let's start with 145 degrees, 13 minutes, and let's go 15 seconds. So you'll notice that we use the same notation as we do for feet and inches, but here you have to understand context and the fact that we're talking about angles. So it's 145 degrees, 13 minutes, 15 seconds. And what we want to do is we want to convert this to some degrees. No more minutes and seconds, just a decimal. Well, here's something I'm going to know. I know it's 145 degrees, point something. So I get rid of that. Oops. 145 degrees, 13 minutes, 15 seconds is going to equal 145 point something. But I don't know what that point is yet. So here's what we have to do. We have to look at each of the smaller parts. And let's start with 13 minutes. And here's where we're going to compare the minutes to what we know about a clock. We know there are 60 minutes in 1 hour. Well, it just so happens there's 60 minutes in 1 degree. So this really is 13 out of 60. This 13 minutes is 13 minutes out of a possible 60 minutes for 1 degree. And the 15, it's the same kind of idea, only since we're going to degrees, I need to know how many seconds are in an hour. Well, we know there's 60 seconds in a minute and 60 minutes in an hour, so multiplying those together, we get 3,600. So if we were to come up here and look at changing this to a decimal degree measure, we would say, oh, this is 145 degrees and 13 out of 60 and 15 out of 3,600. Well, that's pretty easily done on our calculator here. We just type that in. 145 plus 13 divided by 60 plus 15 divided by 3,600. I get a very simple, well, not a very simple, it's kind of ugly, but 145, which is obvious because it's got to be 145 point something. 145.22, let's round to the hundred or the thousands here. 145.221 degrees. So that would be going from DMS to decimals. So notice this out of 60 and this out of 3,600 are very important for us. Let's try another one here. Let's go 25 degrees, 30 minutes, and 20 seconds. Okay, so if we understood that, we know we have 25 degrees and 30 minutes out of a possible 60 and 20 seconds out of a possible 3600. We do some quick math on our calculator. 25 plus 30 divided by 60 plus 20 divided by 3600. And we get 25. Again, we should know that because the degrees has to be the same. It's the decimal part that we're getting. 0.506. Again, we're rounding. Degrees. Okay, so that's pretty simple. The only way this gets any more challenging is, one, if it starts with radians. I'll give you an example of that. But for some reason, if I was to do negatives, it always kind of throws people off. So if I said it was negative 25 degrees, 10 minutes and 12 seconds, some people do some really incorrect math right here. They just follow, they try to follow what I did before. They say, okay, it's negative 25 plus 10 out of 60 plus 12 out of 60. And that's technically not right, because notice what happens if I just plug this straight into my calculator. I get negative 25 plus 10 out of 60 plus 12, out of 3600 on this last one. Catch myself as I'm plugging my calculator. And I get negative 24.83. Well, that doesn't make any sense because I started with 25 degrees and I ended with 24. So here's where that error comes from. That error comes back here. This is not only a negative 25. What you really have to think about is doing the math that we did before and then adding a negative in front. So we actually get, if I redo this on my calculator, and you actually get negative 25.17 degrees. So notice we got the 25 to match, and it's a little bit more. So you really have to think about, let's do this without the negative first, and then add the negative at the end. So we could get a little bit more challenging, obviously. I'm not sure if this textbook does, but let's say I had an angle of pi, let's see. I don't know, let's go pi, I'm trying to think of something good here. 5 pi over 21. Well, if I was to change this is degrees, minutes, and seconds, by the way, so I have to change it to degrees. So I have to multiply by 180 over pi, because that's our conversion factor. And the pi's do cancel, yes, so I get 5 times 180, which is 900, divided by 21. But here I need a decimal because, I got to change this because this isn't the part for this. This is the next page. So let's pause that for a second. And going from DMS to decimals, the hardest thing you're going to get is this negative answer, this negative question here. When you get to the next page here, which is going from decimals to DMS, that's where things get a little bit more complicated. But let's kind of backtrack. Let's figure out how to go from decimals. Let's say I had 13 degrees. Oops, sorry, not 13 degrees. Now I've got myself off track here. 13.1751 degrees, and I want to change this to some degrees, some minutes, and some seconds. Well, I know this has to be 13 degrees. I just got to figure out what's the smaller parts. Well, here's the math that we're going to do. I want to know how much is 0.1751. How much of 60 is 0.1751? So I need to know how many minutes does 0.1751 represent. So I do it really quick. 0.1751 times 60, I get 10.5. Sorry, 10.506. Well, that right there gives you the minutes. So it's 10 minutes. And then I need to figure out what part of this minute is its seconds. So I need to go 0.506 times, well, this is now minutes. This is 0.506 minutes. And I need to know how many seconds. Well, there's 60 seconds in a minute. So I'm going to do that number. So times 60 is 30.36. Guess what? That's your seconds now. So because we don't go any farther than seconds, we can write this as 30.36. It's the only spot where you're allowed decimals in DMS. But if you want to, I'm okay if you just wrote 13 degrees, 10 minutes, 30 seconds. Okay? Or even 30.4 if you just left one decimal at the end. Let's actually do that. Let's get the habit of, if you have a decimal down here, you leave one decimal. Okay, so now I get back to what I was going to say about the radian measure. If I said, I don't remember what it was anymore, 2 pi 21sts, I have to change it to degrees. Oops, did the wrong one. Change it to degrees, so I got to multiply by 180 over pi. So I get 360 over 21. Well, I need a decimal. And this decimal is 17.14285.714. And that's what my calculator says. So I know my final answers is going to be 17 degrees, some minutes, and some odd seconds. So here's what I do on my calculator. I keep that number there, and I just subtract 17. So I get, on my calculator, 0.14285.714. It keeps the whole decimal. So I'm going to subtract 17. And I'm going to multiply that number by 60 to get the number of minutes. So here I get 8.57. So this is 8.57, 1428571, that sort of junk. But I'm going to do the same thing as I did a second ago. I'm going to subtract 8 so I can get 0.57 by itself. And I'm going to multiply that number by 60. And I get 34.3. And you notice that would be our solution. 17 degrees, 8 minutes, 34.3 seconds. And that's going all the way from radians all the way down to DMS. Okay, so I think that should cover it. The only thing else that I want to cover, I want to go over a little bit, is the idea of a radians in my circle, the number of radians. We dealt with degrees. We said 0, 90, 180, 270. This is degrees. Well, we need to go to radians. And also, we also had like 45. We had 30, 45, 60, all those extra numbers, right? We're not going to plug them all in right now, but I do need you to make you think here. This is 0 radians because it's 0. We said that 180 degrees is the same thing as pi radians. And we also said going 1 full revolution is the same thing as 2 pi radians. Well, what are the other quadrant angles is kind of where I want to start. This quadrant angle is, well, it's halfway around. It's halfway to this pi. So that has to be half of pi. Well, if that's half, so that's 1/2, that's 2 halves. There's 3 halves. Oh, that means this is 3 halves pi. That's kind of easy. Well, what if we went to the 45-degree angle? The 45-degree angle is a quarter of the way to pi. So that just means it's got to be pi fourths. Well, if I was to count over to pi, this would be 1 pi fourths. Here's 2 quarters. Here's 3 quarters. So that would be 3 pi over 4. And so on and so forth. This would be 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And again, 8 pi over 4. And 8 pi over 4 is 2 pi. Well, I want you to start thinking critically about if this was 30 degrees, what would that be in radians? You can do the conversion factor multiplying by pi over 180, or you can think about fractions, which is kind of important for us here. If this was 60 degrees, what would that be in radians? And then do kind of thinking a little bit harder for some of these other ones, or just use the conversion factor to figure out what these other angles are going to be in radians. Try to fill out the rest of this circle here and see what you can do. And obviously you can cheat. I mean, anybody can cheat and find this online. But really think about it and really try it. All right? So that's the end of this video. I hope that helped fill in those little gaps that were missing from that first video. All right, see you guys tomorrow.